Hello students, today we are going to talk about NumPy arrays, which is almost a synonym to data manipulation. So we mentioned the 4 types of compound data types in Python, and why do we need a NumPy? NumPy only allows homogeneous data in an array, and which uses much less memory to store data. And second, when using NumPy, you can create an n-dimensional arrays, and it's very easy to change the shape of the array. So let me show you this with code. So here I created an array of like a one-dimensional list from 0 to 9, and I can easily change this to a two-dimensional array with 2 rows and 5 columns. Let's see if it works. Yes, it did succeed. Okay, so that's what means you could easily change the shape of a NumPy array. Third, NumPy array is vectorized, and it allows us to execute mathematical operations on a complete array. And in contrast to list, where you may have to loop through the list and execute the mathematical operations. Let me show you what this means. So I create an array again. And I have another array from 10 to. If I want to add A and B together by each element, A1 plus B1 and A2 plus B2 to generate a new array. This simply could be completed by writing the. You can imagine when we need to add later when we deal with real world data, we often have to add 2 columns together or multiply 2 columns together, and then in that kind of situation, you can use the NumPy array to quickly output the result. And versus if you have a list, let's see what will happen if we do this operation. Okay, let's add C to D. Add these two lists together. Instead of adding each element from C to D, it appended D to C. So this is not the result we want. And probably you have to, what you have to do is for create a for loop, and for I, this is probably the easiest way. And then you can add Ci plus Di until the end of the element. And probably for a list, you probably have to, for a list, you have to do this loop. And the last, it's easy to locate elements in NumPy array. For example, here with the array A, I want to output all the numbers that are larger than 5. So I can just do A larger than 5. And yeah, it will give us the correct result. Now also I can do NP non-zeros and to get to the numbers that are not equal to 0. So let's see if it works. Zero. Okay, here comes. So these methods can help us to locate the elements in NumPy array. Okay, these are the advantages of using NumPy array, and now let's create some NumPy array. The first is a simple one-dimensional array we already did here with A and B is a typical one-dimensional array. And we also demonstrated a two-dimensional array. If we observe this two-dimensional array and compare it to the one-dimensional array, we can see in each two-dimensional array, it composed of in each two-dimensional array, it's composed of the one-dimensional array, and then put the one-dimensional array into rows. So if we use a picture to demonstrate it here, a 1D array is a line. Just have one axis, and a 2D array is like a table. It has two axes, and the 3D array is a cube. So it takes each table from top to bottom. So this is the 0 axis. So it takes the first slice on the top and then goes to the middle, go to the bottom from up to top. Here my question is, what happens if you input this code, and why do we have this the output, and also try to create a 3D array. 3D array with this method. We have just showed in 2D array you have a 1D array, several 1D array forms a 2D array, and for a 3D array, several 2D arrays form a 3D array. So you can try this when we have a break for you to practice the code. We already demonstrated it, so if you want to show the shape of the array, you can just do this. And it tells you the shape. It's a 1D array, and if it's a 2D array, what will happen? Let's see. Array, where did we define a 2D array here? Yes, so let's do this 2D array and then check the shape of. You can see this is the shape of the 2D array. It has 2 rows and 5 columns. And this is the 0 axis and the first axis. You can imagine if it's a 3D array, it will tell us a shape like this. it has 2 tables, and in each table it has 3 rows and 4 columns from top to bottom. Next, we can also create an array with random data. So this code will give us random number from a standard normalization and with 2 rows and 3 columns. So this defines the shape of the array. And if you want to generate a 3D array with random numbers, what should we do? You can imagine just add a number for the third axis. Okay, let's see what it looks like. This 2D array from random numbers from a standard normal distribution. Okay, we just used the NumPy arranger to create an array with a series of numbers. And in last week, we learned range for iterating for loops, iterating a for loop. So what is the difference between range and NumPy range? First, range is a built-in function in Python, and range is a NumPy library function. So whenever you use a range, you have to import the library first. And the main difference between range and range is that the range function returns an iterator instead of a list, and the NumPy range gives you an array. Let's run this code to show you what this means. So if I create a range from 0 to 10, 2 steps, it gives us a type range. So range, we mentioned range is a data type in Python. And if we want to change it to a list, we could do that. That gives us a list. However, with NumPy array, NumPy range, we it gives us an array directly. So this gives us an array. And because range, with range you get an iterator. So range function is more convenient when you need to write a for loop to iterate the values. And NumPy range is more useful when you want to use want to generate arrays and need to get an array of a specific sequence. And then range function only supports integer values lying between a certain range, and NumPy range support other data types. This means is if I want to have steps of 0.1 per step, will this allow us to do that? No, it reports an error. It doesn't allow float object, but NumPy can do this. NumPy range. It's just to do 2. So it will give us an array with a small step. So NumPy can support different data types, and even you can even specify the data type when creating the array. Still do 2 steps, but this time the data type I want is float. They create an array with float numbers. The next thing we are going to talk about is slicing the arrays, selecting a single element or selecting a group of elements. First is how to select a single element. It's pretty straightforward. For example, here, here, if I want to select, let's redefine an array. You want to select one element, and I output this first. And if I select one, this should output this position, because like when we use a range or arrange, the start position is 0. So if we want to get the position, the element on the first position, not first position, on the number 1 position, there should be 2. Let's see if it's correct. Okay, it did give us a correct result. And I can define a 2D array. Just this to reshape it to the same. Um, Likewise, if you select an element, for example, I want to select the first row and the third column, then it should be the first row, so its position is 0. The row position is 0, and the column position is 4th. Let's see if it responds with number 2. Okay, so it's 0, 1, 2, 3, 4. So 0, 1, 2. So this is actually position 2 should be. Okay. And likewise, you can get you can write a statement to select an element from a 3D array. So for example, I redefine this to 18 elements, and then you can do it. Yeah, actually I can use 20, still use 20, as long as all the elements times together is 20. So I'll get 2 groups. See, we generated a 3D array here with 2 tables, and in each table it has 5 rows and 2 columns. So if I want to select the one in the second table and second table, so the first axis is is 1, and I want to select 14. 14, so the second axis position is 0 and 0, 1, 2. This should return 14. Okay. So this should be rows. The row number should be 2, and the column number should be 0. No, it should be correct. 14. Okay. That's how to select a single element. Quite straightforward. And we'll also learn how to slice a certain part uh, from the array, a group of elements. It's actually the same as how we use range and range. When you slice the array, like this array A, use this array A. When you slice the array, you have the start number, the end number, and then the steps. Here, for example, I want to get all the odd numbers. I can do start number is start position is 0, and end position you could say 5. Remember, it includes the end position, so you can do 5 and then 2 steps. Okay, did get the result. And you can either, for this one, if the end position, you want to use the whole array, you can just um, skip the end position. That means you use the whole array. Okay, so here I want to select the okay, let's do this experiment here. So it tells us to generate 9 numbers, and then this should return 3 to position 3 to 6. So it's 3, 4, 5, 6, 4 numbers. And this should be from 0, position 0 to 6, and use every 2 steps. So you can think it should be return 3 elements. You can try this by yourself. If we want to add axis, it's I think you can get it by yourself. For example, here we want to put this square from 6 to 9, then you should get the first no the first axis, the 0 axis is 0, and then the second axis is from number 0, 1, 2, 3 to 4. 0, 1, 2, 3. Then you need to write to 5 because we're including 4. 0 to 5, and you could do just one steps, and the column is from 0 to 1. Just, okay, this should return this area to us. Okay, looks good. So I hope everybody have figured out how to select the arrays. So here I'll leave some question for you. One is how to select a single row or column, and how to select the rows in odd numbers. And last, how to use the negative number to select a row from backwards. Here we defined a new array, a new 2D array here, a 3D array actually, 3D array with 2 tables and then 2 rows and 3 columns. If I run this code, what will show when I'm running the code? Let's read it together first. 0, position 0 to 2. So it wants 2 tables. It wants 2 tables, and then on the first axis it's row number is 1, so we'll get this number, and then column number is 2. So column number is 2, so it's 1 and 0, 1, 2. So it should get the number here at the bottom of each table. Let's see if it works in this way. Has how many elements? 12 elements. So let's another random number. 2, 3. C, output C. Okay, that's give us an array like this. So let's try this code and see if our answer is correct. All right, so this is correct. It did give us the last number from each table. So when we mentioned the 4 compound data types in Python, we talked about whether each data type is mutable or immutable. And this last concept we'll discuss today is the same. whether a NumPy array is mutable or immutable. Let's generate an array again. So can I reassign? For example, I assign value to the first two elements, 0 to 2, 20. Will that work? Will that change the elements in A? So as you see, it did work. So we can say NumPy array is mutable. You can change the elements in the array. And okay. Next, I'm going to define a new array that is taken from this A. I'll do the last two elements. Trying to find. I'll select the last four elements from the array A. So now I change the elements in this slice. Change some elements in the slice. That's two. Okay. 20. So change the elements in this slice, and now let's return to A. As you see, when we change the slice, it also changed the original array, the source array here. Okay, so in NumPy array, when you change the slice, a subgroup from the original array, it takes the view from the array, and when you make a change to the slice, it will also change the source array. So if you don't want to change the whole source array, what you should do is to take a copy of the original array instead of operating on the original array. So you can run these two codes and to compare the difference of different result from these two codes. Okay. We have already been familiar with the function reshape, and here we are going to talk about more functions for manipulating the array shapes. First is the rival, rival, and the flatten. These two functions can transform a multi-dimensional array into one-dimensional array. Both functions produce the same result. And the second one is transpose. This is often used even in Excel. This is very useful feature. So you basically it can transpose the 2 dimensional array. For example, if the 2D two-dimensional array is 2 times, now it's 2 times 2 rows, 4 columns. When it's transposed, it will become 4 columns and 2 rows. So it will be converted 90 degrees. Believe it's easy to understand. Don't want to talk too much about this. And the resize and the reshape, both function change the array changes the array into the shape you want. But the difference is the resize method, it will change the array it works on. It will change the original source. And the reshape, when you run this function, if you want to, it will not change the original source. If you want to change B, you have to reassign it here. Reassign this to B. Then it will change the original source. So you can run these 2 blocks and to see the different result. Next, we'll talk about stacking array. This is often used. You think about the situation. You want to add another table of array, another array to the array, another array to the first array, horizontally or vertically, and these 2 functions can be useful. Let me show you. So I can create a 2D array here. And I create a second array B. B is just 2 times the number in A, 3 times. So if the number in A is 0, it's 0, and the number in A is 1, it will be 3. So let's okay. I need to import the library again. Okay, this is array A and this is the array B. How can we stack them together? Let's do a horizontal stack first. Please notice that here you have to use 2 parentheses. So this horizontal stack takes a tuple, and you have to group them together as a tuple first. On this, and it gives us a new array C. Okay. Here we use the 2 exact same 2 arrays with the exact same shape. So does B need to be the same shape as A? The answer is not. If you are stacking them horizontally, think about this, then B should have the same number of rows, but it could have the same number of errors. Same number of it could have different numbers of columns. For example, okay, here can numpy stack. Okay. I can use A, but for B, I can just take out a few columns. I want to do column. I could do column 0 to 2. So this will give us an array that is shorter than C. It takes has 5 columns. It has 7 columns, but shorter than C. So just try to understand that if the condition, what condition you need to meet when you do the horizontal stack or the vertical stack. For horizontal stack, you have to have the same number of rows, and for vertical stack, if it's a vertical stack, you have to have the same number of columns. So you're stacking them from top to the bottom. So you could delete, you could have different number of rows, but you need to have the same number of columns to make them align to each other. This is the vertical and stack and horizontal stack. Remember, there's another function that can be used for this purpose. That is a concatenate. Concatenate, you can do horizontal stack and vertical stack with the same function, but just change the axis, number of axes. For example, here, with this D, I can also use concatenate. Concatenate A and B, same, exactly the same. But here I need to give it, tell it the axis and to stack them with the rows. So it should give us the same result as the last one. Okay, so this should be axis 1. Okay, it works. So be careful the number of axes. So I was wrong for the first time, for the first attempt. Splitting array is the reverse action of stacking arrays. Notice here you can only split the array evenly. For example, if this array has 6 columns, you can split it into 3 arrays and each has 2 columns, or you can split it into 2 arrays and each has 3 columns, but you cannot split it into 2 arrays, one with 4 columns and the other has 2 columns. That will not work. So here the parameter is the first parameter is the array, and the second one is how many pieces you want to split into, and the third one is the axis. And again, if it's equals to none, 1, then it will split into the array, split horizontally into different columns, split the columns, and the vertical splitting is split by the rows. Next, we mentioned the splitting into the array, split the array into pieces, but more often we don't want to split the array evenly, but just want to take out one rows or several rows. Usually you take out the row at the bottom, or you take out the column at the last position. And in this case, in such cases, you can use the delete function. NumPy delete has three parameters. The first is the array, and the second is the position of the row or column you want to take out. And then the last one is the axis again. So here, for example, use the example we had. We have D, array D, and if I want to take out maybe this 0 and 15, second line, this 0 and 15, this column, I want to take out this column, then I can first give this, I can use this delete function. First I give the array to the function, and then can give the position of this array. And remember, we want to count from 0. First column is 0. The index for the first column is 0. So it's 0, 1, 2, 3, 4, 5. Give it to 5. And then the axis is okay. So when it's delete, it gives us this new array. And let's check if it changed the D or not. So as you notice, it didn't change the D, and if you want to change the D, you have to reassign this result to D. Okay, it can. We just showed how to delete just one column, and you can also do it for multiple columns. I can do it for. I can delete this group from 4, 9, and 0, 15. So I need to give it to a list. List is a position columns on index 4 and index 5. So in this way, it will return the result with this part and this last column. Okay. So yes, this is a delete function. So this function works the same on a 1D array. And for a 1D array, we can do we can delete the elements also by its value or by the condition, by a group of condition. For example, often I want to get the values that are larger than 6, then we can use this Boolean indexing. Let me show you how to do this. Let's use this array D and flatten it first. So for flatten, we also have to reassign. Now I can take out the elements that are larger than 6. Okay, worked. And if we see check D, is still the same. So if you want to change D, you have to reassign this to D. So how this Boolean indexing works is when you do this operation, it gives you an array of booleans. So when you do this, the result returns an array with booleans, false, true, and then if you use this, when you do uh, this brackets, and this gives the array false, true. So when you use this boolean booleans on D, it will take out the numbers that are true, that meets the condition. So for example, 0, it's false. 0 is the false, so it will not get in. And until here, this is 7. This is true, so this 7 will be returned. And 8 is also true, so these numbers will be returned. And when the Boolean number is true on its position. So that's how it works. And this connected to the next thing we are going to talk about is the Boolean indexing. So Boolean indexing, it works the same way as what we just talked about. However, it can work on another array. And here we take these Boolean numbers from D, is D, and then use these to decide whether the numbers in D meet the condition or not. And this D could be another array like E. And this will also work if E has the same number of elements as D. So for example here, I can decide, I can define an array E it should have many elements, 14 elements. So could I have so now I can use this booleans to index E. You see, it doesn't return the numbers in E that are larger than 6. Instead, it returns the numbers on these last 5 positions because this condition, this one gives this Boolean operation gives E an array of false and true. So these last numbers, these last values are true. So these numbers will be kept, and all these will be discarded because they are false. So this is the Boolean indexing. Here in this example, I give an example I give the array 1 is give the example that array 1 is a list of names, and array B is a list of numbers, and you can do the same indexing. Last function we often use is sorting an array. For example, you had to, for a 1D array, you can just sort, and the array will be arranged in ascending order from 1 to 10. So it's ascending order. And if you want to arrange it in descending order, what we can do is we have a couple of ways to do that, and an easy way is to use the indexing, and when you assign the value for assign the parameter of steps, you can use -1 to reverse it. Instead of counting from forward from position 0 to the last position, it will count from the last position to the first position. So this is the sorting, and sorting in descending order. And same with 2D array. 2D array, you when you sort it, you have to specify the indexes. If you sort 1, that means the column, and then the numbers will be in order. Each column, the numbers will be in descending order. And the same method, you can sort a 2D array in descending order. Same. Okay, and note that this sort method is a built-in function in Python, and NumPy also have a function for sorting array. That's you have to write a NumPy sort. Last one I want to mention is the numerical types in NumPy. So in Python, uh, we mentioned that those the basic data types in Python. That's integer, float, strings, and in NumPy it provides more numerical types. And like int, it has integer 8 and integer 16. So the range of these data type is different. Integer A means it takes 8 bytes. It has 1 byte for the negative and positive sign, and then 7 bytes for the numbers. 0, 1, 0, 1, 0, 1 on each position. So it gives us the range from negative 128 to 127. See, so this will be like a sign, negative, positive sign. It could use a 1 or 0 to represent it also. And then it will be a series of numbers 0, no, 0, 1, or 0, 0, these numbers. It has a integer 8, so you can give it 7 numbers, and 2, you can give it 7 numbers, and these 7 numbers makes the integer number. 2 times 7 is 10. That gives you 128. So that's why this integer 8 range from 128, negative 128 to 127. And if you define in default, like when we define define a number with a NumPy range, the default data type is integer 32, but you can define it into integer 8. Then this array will be a smaller size. Let's try this. By default, it should be integer. It should be integer 32. Then let's check the size. And since these numbers are small numbers, I can change it to int. And as we can see here, we defined an array that of which the data type is integer 8, and it returns a smaller size. It uses less space. So this is about the numerical types, and here you have unsigned integer. Those are only positive numbers, and then allow negative numbers. Also here, when you define when you define a data type, when you when you define an array and specify the data type, you can use code. You can use if means a float instead of use a float 32. Okay. Okay. This is a chapter about NumPy arrays. Hope you like it, and you can leave any question uh, under the comments.